Here we are now in the third atmospheric layer of the sun, the corona, where the temperature has mysteriously gone all the way up to 1 million Kelvin. Even though the surface of the sun is only 5,800 Kelvin, somehow the temperature went rising up to 1 million Kelvin. And so how do we explain this? Well, we really don't yet. We have some good theories, lots of scientists working on research that suggests it must have something to do with the way the magnetic fields of the sun are coming up here and interacting with this layer of the atmosphere. But there are still some other details that need to be worked out before we have a full explanation and a full understanding of how this is happening. Why do we even believe that this layer of the sun, that this outer layer of atmosphere is 1 million Kelvin? We talked about spectroscopy showing us that we have discovered there are triply ionized iron atoms in this layer of the sun. You're not going to be able to rip 3 electrons off of an iron atom unless it has collisions with things that are so fast that they would classify as having a temperature of 1 million Kelvin. So there must be a lot of hot stuff moving really fast up here in the corona. Why is that happening? What we're going to move on to is some of the other things that we're actually going to be able to see as visible features in the corona. The corona shows us things that we call filaments and prominences. The corona is where solar flares originate. Other things that we get to see in the corona are things like coronal holes. Let's look at some filaments. Filaments can be up to 50,000 kilometers long. They are also like jets of gas. But these are jets of gas that are a little bit cooler in this hot corona, and because they're a little bit cooler, they would show up as darker streams of gas clouds compared to the background of the sun looking back down on the solar surface of the photosphere. So they appear dark against a hot photosphere, and they're long and thin. Well, a long, thin thing is called a filament. In an incandescent light bulb, you have that coil of wire. That's called a filament. It's long and thin. And so this is like that. Long, thin gas cloud is called a filament. These things can last for a few hours, or they could even last up to months, giving people a chance to somehow get out a solar telescope and maybe take a look at them. But these are the other things that are fun to look at if you get a solar telescope. Something that sticks up above the edge of the sun, like this. Well, this is also something that's like a filament, but you're looking at it from the side of the sun so that you see it coming up above the photosphere, and it's very prominent, isn't it? And that's why they are called prominences, when they're on the edge of the sun. But look over here, this is on the edge of the sun, sticking up prominently, but then when you look down on top of it compared to the photosphere in the background, then it looks long and thin like a filament. And this is something that for some reason I have a hard time trying to get students to remember. A solar prominence and a solar filament are the same thing. It just depends upon the angle that you're looking at it from. So when you look at it from the side and it sticks way up into the atmosphere, it's a prominence. But when you come over and look down on it compared to the background of the sun, then you call it a filament. But they are the same thing.